Okay, this example says determine the temperature of water if it is initially at 273 and has a specific heat capacity of 4,184 joules per kilogram Kelvin. It says the mass is then subjected to 1,000 joules of heat. So basically what we have is we have a beaker full of water, and that water is originally at 273 K, and then we're going to subject it to 1,000 joules of heat. So 1,000 joules of heat is going to flow into the liquid, and it's going to raise the temperature of that liquid, presumably. So it says determine the temperature of water, and then it gives you some information. It gives you that the initial temperature is 273. It also gives you the fact that the specific heat capacity of water is 4,184 joules per kilogram Kelvin. And then it also says that the mass of water is 1 kilogram, and that it is subjected to 1,000 joules of heat. So what we are trying to find in this particular case is we are trying to solve for the final temperature. And the final temperature, the principle that's going to be involved here is the fact that we are talking about specific heat capacity, or the heat's ability to change temperature. So the effect of heat on temperature. The formula is Q equals Cm delta T. And as far as irrelevant information, it doesn't look like I have any. And a lot of people say, well, you don't have delta T. Remember, delta T, anytime you have delta, that's defined as the final minus the initial. So what I can do is actually write out my information now. As I can say, instead of Q, I have 1,000. Instead of C, I have 4,184. Now one of the things that you need to do is make sure that your units cancel out. So I have kilograms and kilograms, and those match. And I have Kelvin and Kelvin, and those match. Because those units match, that's exactly what I need to do. I don't need to convert anything in this case. So 1. And then I have my temperature. Now instead of delta T, remember we write delta T is TF minus TI. Final temperature minus initial temperature. So TF is actually what I'm trying to solve for. And then TI was 273. So when you get to this point right here, you can actually start to rearrange. And what you're going to do is you're going to say, okay, I'm going to divide both sides by 4,184. And what that allows me to do is it allows me to say, okay, it cancels out here. And when I divide it by 4,184 here, I get 0.239 equals TF minus 273. So you can add 273 to both sides, and when you do that, you get the final temperature is 273.239 Kelvin. So even though we added 1,000 joules of heat to 1 kilogram of water, because of the high specific heat capacity of water, we didn't even change it 1 degree.